Good day. I don't know if it's morning or afternoon where you are, so we're going to start with that. This is Miss Fleming, and today we are going to do lesson 4.6. And before we can do lesson 4.6, we have a bunch of stuff to review. So we're going to start with this. All right, all the way back in chapter 1. Let's slide it down so you're not looking at that graph yet. All the way back in chapter 1, we talked about real numbers and subsets of real numbers. And we are going to use this today, so I'm going to go back and review it. Guys, so all the numbers that we know so far in algebra are real numbers. And they break down into, let's get all this stuff up. There we go. They break down into two things. They are either, within real numbers, they are either rational. What are we doing with that? They're either rational or irrational. Okay, an irrational number is easy. They're the small set. They're decimals that never end or repeat. And if you remember, you have a favorite rational number. Let's turn the pen on. And your favorite rational number is pi. And anything that is a decimal that never ends or repeats, it doesn't matter about positive or negative, just goes on forever. So 1, 4, 7, and I know it goes on forever because of the dots at the end. We don't really need to review the whole thing. I just need you to remember that that's what an irrational number is. Okay, rational numbers, on the other hand, are anything that can be written as a fraction. Are they decimals that end or repeat? So if I have a fraction such as 1/2, which can also be written as 0.5, and again, it doesn't matter if they're positive or negative, that has nothing to do with this. All right, now integers are going to be important today, whole numbers are going to be important today, and natural numbers are going to be important. Okay, integers are a subset of rational numbers, which are a subset of real numbers. Integers have a 0. 0 isn't positive or negative, but integers also have all of the negatives on this side. And of course, these continue, so let's put some dots here. And then they have all the positives on this side. All right, now, whole numbers are also integers, but the difference is whole numbers don't have any negatives. So whole numbers start with 0, and then 1, 2, 3, and so on. They go on forever at this end. All right, there's only one difference between whole numbers and natural numbers. Natural numbers do not have 0. So they start with 1 and go on from there. Okay, are you interested yet? Intrigued about what we're doing today? So remember subsets of real numbers, because the next thing we're going to go back and look at is domain and range. So let's erase this. You don't have this anywhere. It's not included in the lesson. Let's do this, because this is all review before I even get to the lesson. All right, you remember domain and range. We're going to review domain and range really quickly. Okay, in this lesson, I will give you this hint. We're going to find domain and range from word problems. And when I do that in a word problem, it is really important that I know where the independent and dependent variable are, or what they are, rather. And then we're going to do the exact same thing we've done here. We're going to find the first value and the last value and so on. All right, so x is right here. And x is the independent variable. And x is where I'm going to find the domain. Okay, y is here. Y is the dependent variable. and y is the range. Okay, so we're going to find the first and the last value for the domain, and we're going to find the first and last value for the range, and that's going to lead us right into what we're going to do for this lesson. It'll all make sense why we're doing this in a minute. Okay, so from left to right, I always go from the negatives to positive. The very first value I have for my domain starts right there. Okay, so let's start writing it out. I write this as an interval. My first number here, let's see, -5, -6, it starts with -7. I'm going to have an x in the middle. And I end right here. My last value for this is right there at 5. Okay, I've got an open or a closed circle here, so this one is going to be less than or equal to. And this one is open, so this one is just going to be less than. All right, so here's some other hints. We're going to be doing word problems, so we need to identify the independent variable, so we know the domain, and we're going to find the first and the last value. Same thing for the range. Let's change to a different color so it's a little easier to see. Okay, the range starts down here, and my first value for my range, that's a great big dot, so we're going to assume it's right here at -3. So my range, the first value, or where it started, is at -3, and where it stops is right there at 1. I have a y in the middle, and this is a closed circle, so it is less than or equal to. That's an open circle, so it's just less than. So let's see how we can translate this into a word problem. Let me shut this down and get the lesson open. All right, lesson 4.6. You're like, wait a minute, we've been working with polynomials for the last couple of weeks. What are we doing back with domain and range? Sometimes things just sort of fall out of order, and this just happened to be one of them. But we've learned everything up until this point with domain and range, so it's a good place. All right, so we've just been working with intervals. Let's go through the vocabulary. Interval is a set of numbers that contains all of the numbers lying between any two numbers. So here's my example. My interval starts with 0, it ends with 1, and all of the numbers in between 0 and 1, which could be a whole bunch of rational and irrational numbers, which would be all real numbers, between those are part of this interval. And we are going to write our domain and range as intervals today. Okay, what is a constraint? A restriction, which could be called limitations or boundaries, that needs to be placed upon variables used in equations that model real-world situations. You're going to see how we use a constraint. I'm going to use them several times in the examples. All right, we have looked at continuous and discrete graphs. We need to revisit this. Continuous data is data that can be any real number within an interval. That's confusing, but here's something more straightforward. Continuous data are values that can be measured. Okay, here's an example. People's heights could be any value within whatever human heights can be, but not just any certain fixed height. So you might be 5'7.5" tall, but chances are you're probably not exactly 5'7.5" tall. You're some number between 5'7¼ tall and 5'7.5" tall. So it's continuous because you can't exactly say it's exactly this number and only this number. It's never anything else. On the other hand, data that is discrete is very, very specific. And we've seen this on a discrete graph. And these are values that can be counted. I can identify very specific values. Here's an example. The results of rolling 2 dice are 2, 3, 4, 5, 6, 7. Because if I roll 2 dice, they can be both ones. I can have one that's 1 and a 2, 2 and 2, 2 and 3, and so on. There's no 2.5, no 2.5. They're going to be very specific numbers. All right, so we're going to start off and then we're going to get some thoughts about how this is going to work, and then we've got some examples. Okay, we've got some instructions here. Organize the ordered pairs from the set into a table. So we've seen this before. Use a table. It makes things really easy to see. It gives us a way to think about all of this random information. So we're going to have X's and Y's. Let's get rid of the green because I'm sort of tired of it. And we put our X's here in this T table. Our Y's here. My first X is -2. I'm not concerned about ordering at this point, in least to greatest or anything else. I'm just going to write them all down. -4, -6, -8, -10, and -12. So if I were anticipating where this lesson's going, right now I have found my domain because that's my X values. All right, now I'm going to do the same thing with my Y's. I've got a 0, 3, 6, 9, 12, and a 15. These are my Y's, these are my dependents, and these are my range. Okay, is it continuous or discrete? Well, I've got very specific numbers here, so this is discrete. And I'm just going to put DIS for discrete. Okay, is it a function? Does each input have one output? I don't have any repeats on the X's, so yes, it's going to be a function. Okay, now we're going to use interval notation to describe the domain. We're going to say what subset of numbers it is because it is not all real numbers. And we're going to see if we have a constraint. So my domain starts with -2. And it includes -2, so it's going to be less than or equal to. That's why you have to organize it from least to greatest. It's a domain, so it's X's. And I end here at -12. That's my last value, and it includes -12. All right, now, what subset of real numbers are we using here? Okay, we don't really need to do all real numbers. That would be way too broad. If we did just rational numbers, that would include things that had decimals or fractions. We don't have any of that. And I don't see any positive numbers here. So I'm actually going to describe this as being negative integers. Because that's all I've got. Okay, now there's something else going on here. -2, -4, -6, -8. I don't have a -3 and -5, so I can't just say it's negative integers because between here and here, I would have -3, -5, -7, and so on. So what else is going on here? 2, 4, 6, 8, 10. Not only are these negative integers, here's my constraint. They are even. That's all they are. I don't have anything but even numbers. There's no odd numbers in that set. So that is how I would describe this domain. Now we're going to look at the range. Well, the range starts at 0. And it includes 0, so we're going to say less than or equal to. And my last value for my range is 15. So this is also inclusive. All right, now I've got other choices. This is still integers, but this time it is non-negative integers, which is awkward. We can't say positive because 0 is not positive or negative. How about if we describe this as whole numbers? That would work. Let's put that. Ooh, that's really close together. Let's get rid of that. All right, these are whole numbers. And it's not all whole numbers, because if I look over here, I don't have a 1 or 2, I don't have a 4 or 5, but everything up here can be divided by 3. I'm not going to put divisible by 3. What I'm going to say is multiples of 3. And we've seen that before. Back when we did 2.6 with more domain to range. All right, so this is what we're going to look at word problems. We're going to describe the domains and the ranges with intervals, subsets, and constraints that they comply or apply. They don't all necessarily have a constraint. They will all have an interval and a subset. So let's erase this and go to the first example. Let's not go too far. All right, here is our word problem. We have John, and he has an after-school job where he makes, let's turn that pen on again before things start to get too jumpy, where he makes $5 an hour. He never works for more than 20 hours a week. What is the domain and range for the situation? Okay, well, I've got, just take a minute to look around here at a tour. I've got a T-table, and I've got a question here that says, can you write an equation or make a table with the information that's been given? So I've got a couple of things here to help me organize my thoughts. And you aren't necessarily always going to be able to write an equation or even make a T-table. These are here as tools to help you find the domain and range. So don't get caught up in, did I do the table correctly or anything else? Also, I'm going to warn you, this is one of those lessons that's really, really wordy. And the goal here is not that you can write out these perfectly worded. The goal here is that when we get to the Case 21 test or the state test, that when you get one of these problems put in front of you, that you know what they're asking you, and that you know how to find it, and you know how to read the information you've been given. So don't get all hung up on all these other things around you. That's not what's important. What's important is, do I understand what's going on, and can I describe it? So once again, Joe has an after-school job. He makes $5 per hour. He never works more than 20 hours in a week. Okay, well, right there, I know that I've got a rate of change because I've got the word per. And that gives me all kinds of useful information. I can look at that and go, well, I've got hours and I've got dollars, and I know that rates of changes are always y's over x's. So I've got $5 over hours. And since I have done that, I have what my independent and dependent variable are. My independent variable is going to be time, and specifically it's in hours. So it's the number of hours that he's going to work. And he is earning some kind of money, so that's all I'm going to put down there. I'm going to put earnings, and the units that he is earning in is dollars. All right, now, he never works more than 20 hours. We know this is hours, which is X, and we know that this is money. And you'll see the table is really helpful. Okay, he's not going to work more than 20 hours, so somewhere down here I've got a 20 because that's where this is going to stop. I already know where this ends. Okay, is it possible that he could work 0 hours? Yeah, I would say that's possible. If he doesn't work at all. He could start at 0. Okay, we're going to assume that he only works in full hours. So let's say that he works 1, 2, 3, and we're going to go all the way down here. We're not even going to fill in the whole table. But we know he's never going to work more than 20 hours. He makes $5 an hour, so the first value for my domain is 0. And if he works 0 hours, he's going to make 0 money. If he works 1 hour, he's going to make $5. If he works 2 hours, he's going to make $10. If he works 3 hours, he's going to make $15. So this just got really easy. All right, if he makes $5 an hour and he works 20 hours, what's this last value of the range going to be? $5 times 20 is going to give me 100. Now, I think at this point I could write an equation. I've got a y-intercept right here. I've got a rate of change. This would be my initial value. So I could write an equation, but at this point I don't really need one. But let's go ahead and write it anyway, since we know what it is. There's my $5, which is my rate of change, and there's my hours. All right, let's find my domain. My hours start with 0. This is my interval. This is easier than you thought it would be, isn't it? And it includes 0. And it ends with 20. And what numbers are we using here? We've got zeros, so they can't be natural. I don't see any negatives, so let's go ahead and call these whole numbers. And let's see if we have a constraint. 1, 2, 3, 4. I would just keep going between here. I didn't write them all down, but there's nothing that would say that I wouldn't have every number in between here, other than it would take a lot of space. So they just keep going. There's nothing that's missing here. So it's all whole numbers. So there is no constraint. We leave that open. All right, let's look at our range. It starts at 0. And it includes 0, so it's less than or equal to. And the last value of my range is 100. Okay, again, if I'm going from 0 to 100, I can see already I'm going to have some kind of constraint. But I don't have any negative numbers, and I have a 0, so it can't be natural numbers. So I'm going to call this one whole numbers as well. But this time I have constraint. 0, 5, 10, 15, and so on. Everything that's in between here. These are multiples of 5. Is this easier than you thought it would be? And that's no surprise because what am I doing? I'm multiplying by 5. All right, one word of caution before we go on. I ran that together really bad again too. Let me separate those out. We describe these as whole numbers, and that is completely correct. There is nothing wrong with calling these whole numbers. But you might end up with a description that says these are integers. Okay, 0 is not positive or negative. So if they say that we want to describe these as integers, we can't say positive integers because 0 isn't positive. What we can say is non-negative. Great word, right? They would be non-negative integers. I'm not going to make you do that, but I want to point it out. Okay, we've got a couple more examples, so let's keep going. All right, this one gets interesting. And this one came right off of a Case 21 test from a couple of years ago, other than it wasn't tokens. It was something to do with the parking meter. So I rewrote it so that we could get it in front of you so you could expect or see something that looked like it. All right, that was a lot of words for something. At an arcade, red tokens are worth 5 points. Blue tokens are worth 15 points. The attendant empties the machine and retrieves 150 points in tokens. What is the domain and range? Okay, the first thing I need you to recognize is I don't see a rate of change. I do have a total here. And I've got 5 points and 15 points. There is no independent variable here. There's no rate of change. There's no initial value. This is actually in standard form. So we're not going to write an equation, and we don't need to. We're going to take these in the order they were given, and we're going to say that red tokens, which are worth 5 points, are going to be X. And it's strictly because that's what order they're in. So this is the number of red tokens. And I am going to use this table, so I'm going to put it here. These are red. And we just said that red was X. Okay? Poor thing. All right, then that leaves me with blue tokens, and these are the blue. Okay, the other thing I need to carry over that table that's really important is that red tokens are worth 5 points. And blue tokens are worth 15 points. I need to know the point value because at some point things are going to total up to 150. All right, now let's say she empties out, we don't know if it's a she, the attendant emptied out the machine, we had 150 points. It's very possible that all of those points were blue. Let's start with the y-intercept. Okay, so if I have 0 red tokens, how many blue tokens would that leave me? 150 divided by 15 says that that would give me 10 blue tokens. Okay, what if I had 1 red token? Now I've got, take 5 out of this. This is going to get a little interesting. If I take 5 out of that, that leaves me, oh, that's interesting. I just looked at how the way somebody else had worked this. Ah, okay. Don't want to do that. You're seeing me being enlightened because I'm reading somebody else's notes. All right, if I have 1, I actually can't do that because that would leave me with 145. I don't think that will work. Pick up your calculator and see if you can divide 15 into 145 evenly, and I think that's an issue. And I am getting a calculator. And that is exactly the problem. I can't have 1 red token because it won't do, 145 and 15 don't divide evenly. So where I'm going to go next, I'm actually going to try this the other way. If I put 2 tokens in here, that would leave me with 140, and again, I can't divide 15 into 140 and come out evenly. So I'm going to try 3. And you're like, this was on case 21? Yes, it was. If I have 3 red tokens, that will leave me with 9 blue tokens. Okay, follow with me. 3 times 5 is 15. 150 minus 15 leaves me 125. If I divide that by 15, I get 9. Let's see if we can find a pattern. Let's go ahead and try 6. Okay, so 6 times 5 is going to give me 30. That's going to be 30 points. So I have to have 120 points here. So will 15 divide into 120? And it will give me 8. All right, now before we start doing a whole ton of elaborate math, let's see if we've got a pattern here, because I think we do. Okay, it looks like if we increase the red tokens by 3s, then our blue tokens will decrease by 1. Let's see if that holds true, and we are going to 150 points. Okay, so 3, 6, 9, 12, and we're going to keep going. So we've got 7 and 6, and I'm going to go till I have 0 blue tokens. 5, 4, 3, 2, 1, and 0. So I started with 0 red and 10 blue. I'm going to end with 0 here. let's fill this out. So I've got a pattern where I'm increasing by threes, 15, 18, 21, 24, 27, and 30. All right, so one more time. This got really complicated, but let's see. If we had 0 red, we need 10 blue. We couldn't have 1 red and have something here that divided evenly to what was left over. And the next number that would let us do that was 3 red, which was 15 points, which left us with 135. Oh. Yeah, sorry. And 135 divided by 15 left me with 9. That's a lot of stuff, but follow this down. If I keep increasing these by threes until I get to 30, 30 reds, multiply that by 5. 3 times 5 gives me 150 points here, and that would leave me with 0 blue tokens. So you don't have anything like this in the practice, but you might have something like this in Case 21. I can't promise. There was a parking meter problem like this. We're not going to try and write an equation, but we've got everything we need to describe this domain and range. So my interval is from 0 to 30 on the reds. So 0, all right, I don't have any negative numbers. I don't need integers. I do have 0, so I'm going to go ahead and describe this with whole numbers again. And I do have a constraint because these are multiples of 3. Okay, my range on the other hand. Now, be really careful here. You have to write these from least to greatest. Remember, the range goes from the negatives to the positives. So we have to actually start with 0. And we're going to end with 10. And these are whole numbers again. And there is nothing in between these. These were missing 1 and 2, 4 and 5, so we knew we needed a constraint. But these are 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, so there is no constraint here. All right. Oh, wow. Another parking meter problem. No, this one's easy. All right. Next example. Clear this one. Okay. A parking meter accepts quarters for 30-minute time slots. So every 30 minutes, I have to put a quarter in this parking meter. Or I have to put enough quarters to cover how much time I'm going to be in there. You could be parked there for as long as 3.5 hours. What is the domain and what is the range? Okay, well, I am giving it quarters. So something is going to be quarters. And, or at least a cost that's in quarters. And then I have 30-minute time slots. They're not hours. They're not single minutes. They are, in fact, 30-minute time slots. And I'm going to be there for 3.5 hours. So how many 30-minute time slots are there in 3.5 hours? Let's figure it out. Well, a half an hour is 30 minutes by itself. So let's convert this from a mixed fraction back to a regular fraction. So 2 times 3 is 6, plus 1 is 7. So that tells me that I've got 7 half hours that I'm going to be parking there. So I could park there. Let's see, this is my X. This is my Y. I could park there for 0 time at all, but I could be there for 7 half-hour time slots. Well, I'm not going to write 7 halves. That doesn't make any sense to me. These are 7 time periods that are each a half an hour long, or 30 minutes. So we're going to actually just say that our time independent variable here is a number of 30-minute slots. You could say half-hour slots if you wanted to. And what I'm going to do is I'm going to feed quarters into this. And I don't want to say number of quarters. I want to know how much I'm going to put in there. So I'm going to put, let's call it just the cost of parking. I'm not going to say, and I'm not going to say in quarters, and it's in dollars. All right, if I park there for no time at all, I'm not going to pay anything. If I park there for one 30-minute time slot, I'm going to pay 1/4, which is 25 cents. If I park there for 2, I'm going to pay 2/4, which is 50 cents. Remember, these are 30 minutes. Okay, so if I go for 3 30 minutes, this is going to cost me 75 cents. If I go for 4, it's going to cost me $1. These are going up by quarter, which is 25 cents every time. If I stay there for 5, it's going to be $1.25. If I stay there for 6, it's $1.50. And how many am I going to stay there for? 7. And that's going to be $1.75. All right, can we write an equation? Yeah, I could write an equation. I know that I'm going to put in a 30-minute time slot. I'm going to get out the cost for that, and I know that it's in 25 cents. And I know that my y-intercept, or my starting value, is 0. So I could write an equation. I don't have to. I made a table, but it's nice to have an equation. So the number of time slots times 0.25 is going to give me the cost that I have to pay. I've got everything I need to write my domain and range. I start with a 0 and I end with a 7, and it includes 0. And there's nothing that's missing here, so I don't have to put any multiples or anything else, or evens or odds or anything else. This is just whole numbers. Okay, then I've got 0, 0.25, 0.50, 0.75, so I'm going to start at 0. And my range is going to end at 1.75. These are not whole numbers. They're not integers. They're decimals that ended. So these are actually rational numbers. And there has to be a constraint here because it doesn't include all the decimals in between 0 and 0.25 or in between 0.25 and 0.50. It gives me decimals that are multiples of 0.25. All right, so here's what you're going to do. When you get into the practice, you're going to read carefully. You're going to see if you can figure out what your independent variable is and what your dependent variable is. That's going to let you set up your table or write your equation or do both. And I'm going to put enough information on my table so I know what I'm talking about. And that was really a problem with the red and blue tokens because clearly I even got lost. All right, so once I figure out how to label my table, then I'm going to say, okay, where did I start? Did I start with 0 or did I start with 1? And I can figure out where I started, and there should be enough information in my problem to tell me what my last value is going to be. Then I can figure out my first and last value over here. After that, this becomes really simple. My domain, where did it start? Where did it stop? That's my interval. What kind of numbers do I have? Do I have whole numbers, integers, rational numbers, natural numbers? And do I have to worry about missing numbers? If I do have missing numbers, then I'm going to have to include a constraint that's going to be something along the lines of multiples of something, or even numbers only, or odd numbers only. So, again, there's going to be a lot of words. You're going to get frustrated by the wording. The goal is that when you get a problem like this on the state test or on case 21, that you understand what's going on and that you know how to read this and you know how to read the answers and you can describe the domain and range. They're going to give you the wording. It's up to you to be able to understand what you're looking at. So enjoy, and I'll be up some later video. Have a good day. Bye.